Good day guys, and welcome back to our second video. So in our second part we are going to derive some expressions here. So the very first one that we have here, that is 2.1, it says that we must differentiate y with respect to x if y is equals to 3x squared times a cube root of 8x to the power of 4. So the very first thing that we are going to check is whether this expression is simplified. We check whether there's a z. We check whether there's x on the denominator. Remember that we are differentiating with respect to x. So we must check whether is there x inside a radical sign, and then is there x on the denominator, and then is our expression simplified, and that the y is the subject of the formula. So right, when you look at this expression here, we have x here inside of the radical sign, and what we have to do here, we can just simplify this in this instance. So we are going to have that y is equals to 3x squared times, and then remember the nth root of a times b is the same thing as the nth root of a multiplied by the nth root of b. Remember this from the laws of sets, right? So when you look at this here, so I have the cube root of 8 times x to the power of 4. This is the same thing. This is going to be the same thing as the cube root of 8 times the cube root of x to the power of 4. So when you simplify this, you're going to get that this is going to be 2, and then this is going to be x to the power of 4 over 3. So I'm just going to write that this is 2 x to the power of 4 over 3. All right, so this is what we have here. So now we have changed the radical sign, and this we have expressed it in the form of an exponential form. So now, in order to move forward in this instance, we are going to check whether our expression is simplified, and we see that our expression is not simplified. So we have to simplify it further. So you are going to have to multiply this with this. Right, so and 3 times 2 is a 6. Then x to the power of 2 times x to the power of 4 over 3. This is going to be a 10 over 3. So this is x to the power of 10 over 3. Remember, when you multiply powers of the same base, you are going to add the exponents. And that is how we are going to add this so that we get a 10 over 3. And then now, since now our expression is simplified and y is the subject, it means that now we can differentiate with respect to y. So it means that now when I differentiate, I write the notation that is dy dx is equals to, so remember here we are going to have a 6 times 10 here. 6 times 10, which is a 60. 60 divided by 3 is going to be 20. So I'm going to have a 20, then x to the power of, then 10 over 3 minus a 1. So 10 over 3 minus a 1. This is going to be equals to a 7 over 3. So you can write this as a 7 over 3. So that is what we have here when you differentiate this using the power rule. Now moving on to 2.2. So this one here says that we must differentiate y with respect to t. So we are going to check whether we have t as a denominator. We check whether do we have t inside a radical sign, and we check that the expression is simplified. But when you look at this expression here, it's not simplified. And if it's not simplified here, it means that we must simplify it first before we differentiate. All right, so we are going to have that y it's equals to, so we are going to distribute here, and that is going to be a 3t minus a t multiplied by a t. That is going to be a 3t squared. Then when you multiply a t with a negative 7, you're going to get a negative 7t. You multiply a 1 with a 3t, you're going to get a positive 3t. You multiply the 1 with a negative 7 here, in this instance is going to be a negative 7. All right, and then you further simplify this. This is going to be 3 t squared, then minus 7t plus 3t. This is going to be minus 4t, then minus 7. Right, so now our expression is simplified. There's no t inside the radical sign. There's no t as a denominator. Right, so, and y is written as the subject of the formula. Therefore, we can differentiate. So I'm going to write that dy and dt, and this is going to be equals to 3 times 2, which is a 6. Then 2 minus 1 is going to be 1. And then I'm going to have a 1 times negative 4, which is going to be a negative 4. 1 minus 1 is a 0. And then remember that t to the power of 0 is going to be 1. And 1 times negative 4 is still negative 4. So this is just going to be negative 4. And the derivative of a constant here is going to be a 0. So when you differentiate this with respect to t, we get that 6t minus 4 as our answer. Right, so now moving on to 2.3. Now with 2.3, we have to find g prime of x. Right, if g of x is equals to open bracket 2x minus 1 over 2x all squared. Right, so now when you're looking at this here, it is clear that our expression here is not simplified. And if it's not simplified, it means that the very first thing that we are going to do here is to further simplify this expression here. So now when you simplify this, we are going to square the 2x. You are going to get 4x. So I write that g of x is equals to a 4x squared. I multiply 2x with negative 1 over 2x. I'm going to get a negative 1. Negative 1 times a 2, I'm going to get a negative 2. All right, then I square the negative 1 over 2x, and then when I do that, I'm going to get a positive 1 over 4x squared. Right, so this is what I have. So our expression is simplified, but I have a problem here. Remember, I want to differentiate with respect to x. Therefore, x should not be in the denominator. So when I do this, I'm just going to change this and write it on the numerator, but with a negative exponent this time. So I'm going to have that g of x is equals to 4x squared minus 2. Then this is going to be now plus x to the power of negative 2 all over 4. And then remember, we are just differentiating with respect to x. So there's no need for us to take the 4 to the top as well. So in this instance, since we had one term on the denominator, it's much more easier to just take the 4 to the top, the x to the top, so that it becomes an x to the power of negative 2. Right, rather than taking the 4, because it's not necessary to do that. So we are going to have that g. So now we no longer have x on the denominator. Our expression is simplified. Then it means that we can differentiate here. In this case, we didn't have any radical sign. So you're going to have that g prime of x. So with the g prime of x, you're going to have a 4 times 2. 4 times 2, which is going to be an 8. Then x. Then 2 minus 1, 2 minus 1, which is a 1. Then we are going to have the derivative of a negative 2, the derivative of a constant, which is going to be 0. Then we are going to have the x to the power of negative 2. That is going to multiply the coefficient of x here. That is going to be a negative 2. And negative 2 divided by a 4. This is going to be a negative 1 over 2. And then x to the power of, then remember here in this instance, you are going to subtract 1 from the exponent. And this is going to be a minus 3. Right? So that is how we are going to differentiate this particular expression with respect to x. Now, moving on to 2.4. So for 2.4, we can already see that our expression is not simplified. So the first step now that we are going to do is to first simplify this. Remember that this is not simplified because it can be simplified further. Right? So when I simplify this, I'm going to have that d x. Then remember, this is the same thing as when I have the two brackets. And when I simplify this is the same thing that I'm going to have a 2x minus a 3 and also a 2x minus a 3 all squared. Right, but when I simplify this, I'm first going to simplify this particular bracket here. And this is going to be d x, and then we are going to have that this is 2x minus a 3. Then when I further simplify this is going to be 4x squared. Then 2x minus 3 is going to be minus 6x. Then minus 6x multiplied by 2 is going to be minus 12x. Then minus 3 all squared is going to be a positive 9. And then we are going to have to simplify further again because we can still simplify this. Right, so we are going to have that dx. Then 2x multiplied by the 4x squared. This is going to be an 8x cubed. Then 2x multiplied by the negative 12x. This is going to be a minus 24x squared. Then 2x multiplied by the 9 is going to be a positive 18x. Then negative 3 times and 4x squared. This is going to be a negative 12x squared. Negative 3 times a negative 12x. This is going to be a positive 36x. Then negative 3 times the 9, the negative 3 times the 9, then this is going to be a negative 27. Right, so this is a negative 27 here, but we know that we can further factorize this because we have like terms. So we are going to have that 8x to the power of 3 because it doesn't have any like term. But we notice that we have a minus 24x and a minus 12x squared. So with the 2, what is it that I'm going to do here? I know that when I minus 12 from minus 24, this is going to be a minus 36x squared. Right, so from here 18x plus 86x. So remember that 18x plus 36x, this is going to be a positive 54x. And then again we are going to have a minus 27. Now with the minus 27 here, in this case it's just going to be a minus 27 because it doesn't have any like term. Right, so we are going to further simplify here. We see that we cannot further simplify in this case because we don't have any like terms anymore. So this is expression here, it's simplified, and there's no x on the denominator. There's no x inside the radical sign as well. So it means that now we can differentiate. And now with this notation, when you differentiate, you get rid of this brackets here and the notation here dx. Right? So you keep on writing it up until you differentiate. When you differentiate, then you get rid of the brackets and the notation dx. So 8 times 3. So with the 8 times 3 here, this is going to be 24x squared. And then when I differentiate negative 36x, this is going to be minus 72x. I differentiate the 54x, this is going to be just the 54. And when I differentiate the negative 27 there, it's going to be a 0 because it's a constant. So that is what we are going to have here when we have differentiated this. So this is what we had for our second video. But please stay tuned for our upcoming videos as well that are also going to be addressing the challenges or various types of questions that can be asked or assessed in the derivatives type of questions.